We look at AI very differently. Again, we are a health platform, so we have to be very responsible in terms of what we offer to our users. We've been a little conscious in terms of how to showcase AI in the workflows, because we've not achieved AGI yet. So it does make mistakes, but I think we are very, very bullish on the technology internally, right? I think there is no work that happens which doesn't use it inherently.
How many times did you change the electrical design in the last year, 12 months for the Ring Air?
I think every month at least 1 to 2.
So maybe 20 times in the year, you've changed the electrical
Yeah.
design of the device. That's unbelievable. Most of the products I've worked on might roll out one electrical change over the 3 year that the product is in market for a consumer device.
One interesting element of our hardware is that it's worn 98% of the time across the day. Right? So now what that means is that it is always damn on, right? That means that either people just put it on charger, otherwise it's always on the body, right? So if the device is actually active and sending data, that's like the holy grail and the bread and butter in some format, right? So we have to make sure that, that the device is always sending raw markers in some form or the other.
Welcome to Coredump Sessions, the podcast for IoT leaders, firmware engineers, and embedded systems enthusiasts. Each episode, we bring you insights from the leaders and innovators shaping the future of connected devices. We'll talk about what's breaking, what's working, and what it really takes to build reliable products at scale. Let's jump in.
Hey everyone, and welcome to today's Coredump live session. Today's session is on building and scaling a startup in the ultra-competitive health wearable market. I think we could say building in consumer electronics, it's not for the faint of heart, and today we're going to dig into what it takes to be successful. For those tuning in live, thank you for being here. One of the benefits of joining live is that you can shape the conversation. Just use the Q&A button to drop in your questions at the bottom of the screen, and we'll get to them towards the end. All right, so who do we have today? I'm delighted to introduce Vatsal Singhal, an experienced co-founder with a strong background in consumer tech and new age technologies. Vatsal is currently the co-founder of Ultrahuman, a company that specializes in developing innovative products that help improve the physical and mental health of their users. Before founding Ultrahuman, Vatsal worked as the associate vice president and head of product and engineering for the listing business at Zomato, where he was responsible for managing their big data platform. Prior to that, he co-founded Runner, a B2B last mile logistics platform that helps small and medium enterprises in India book, track, and manage customer deliveries. Runner employs more than 150K people and is present in more than 150 cities. Very different business from hardware. Welcome, Vatsal, and we're so glad to have you here today.
Yeah, thank you guys for hosting me. Very, very excited to be here and looking forward to the conversation.
As always, I'm François Baldassari. I'm the VP of Software Services at Nordic Semiconductors. Previously, I founded and was CEO of Memfault, and my co-founder and our tech side leader, Chris Coleman, is joining me from Boston. Hey, Chris, how you doing?
Great. Excited for another great conversation.
Okay, so Vatsal, many of the hardware entrepreneurs we talk to come from the hardware side. They've built, they've gone from electrical engineering to firmware to software. They figured how to build the whole system. But you're one of the rare folks who actually comes from the software side. Very different background from mine. So maybe tell us a little bit about your background and how you found yourself starting a health hardware company.
Right. So I think my background, of course, is, I'm a computer science engineer. I think always loved solving problems and never knew, we'll jump and solve, health as a problem statement. I think like since the beginning of my career, I've always loved writing software and that's what I've done as a career. But I think never knew that hardware is going to become such a core part of the business that that we will eventually build. I think it always thought of solving problems first, and then how technology can actually make an impact. I think hardware was when we identified that, okay, this is a problem to solve for. Now hardware is the only means to the end is when we jumped into solving and picking hardware as a technology, and then like actually thinking first principles that how do we identify even what is a PCB, how do you build it, right? And of course in your engineering, or when you study, you study hardware as a side subject, and you're like, we know some things, but you don't know a lot of things. When you actually start implementing a lot of these things, you realize that you don't know anything, to be honest, right? So I think we learned a lot building software, and I think those learnings we are putting in into our hardware iterations as well.
So was it the space that attracted you first, and then the hardware part became a conclusion of your tinkering and problem solving? Do I understand that right? You said there's a health opportunity here, and then you realize, wow, well, I guess hardware is the only way to do this. Or was it, well, you started with, I want to build something, I want to build a piece of hardware, and stumbled upon the health opportunity?
Right. So I think the previous startup that I was doing, again, like you mentioned, was called Runner. And, it was completely different. It was, like a hyper local logistics company where you press a button, you get a delivery boy, and you can ask, that guy to do anything. Like, for example, deliver your laundry, get food for you, get a package delivered. And most of our, like delivery boys would actually do food ordering, right? I mean, they would, like, people wanted food. That was the primary use case back then. And we realized that like as we scaled and became a large company, we realized that food is becoming such a fundamental part of the world, where everyone wants food in like 5 minutes, 10 minutes, and and the food that people were ordering were actually we know things that can be cooked quickly, right? For example, burgers and pizzas and like pre-made food items. So I think, like, as we scaled that business massively, it of course became very, very successful. Now like we became part of a company called Zomato, which is now listed at, I think, 35 billion, and it's doing really well. I think learning for us was that, of course, people love ordering food, and like they really want to eat everything that is out there, but now the tide is changing. Everyone now is focused on improving their health. I think like both me and Mohit, even in that journey, we were very passionate about health, and wanted to build something grounds up. So I think health became the problem statement, and I think we didn't know how to solve it back then. We had no idea what is the true solution for solving for global health problems. But I think we knew that this is what we want to do, and then we stumbled upon like data, stumbled upon how do you measure it, what algorithms can be used, and we need hardware as well for that.
Awesome. And oftentimes when I talk to software folks who join a hardware company or get into the hardware world, so their first reaction is, wow, this is way harder than I thought. But you go in there thinking, how hard can it be? Design a PCB, put it in a box, shipping around the world. And then, you get faced with the reality. So
Yeah.
for you, what's the thing that ended up being hardest? What was the biggest slap across the face when you went from shipping an app to building this hardware product?
I think the beauty of software is that you press a button and you get the output, and the user gets the app, right? So the chance of failure is actually very, very low. Meaning, the worst that you can do is that your app can go down, and then you can fix it, right? That's the worst that you can do. But I think in hardware, we realize that if you ship a bad hardware, there's nothing that you can do. You can't fix it. There's there's no remote way of fixing a circuit that you've made wrong, right? So I think that realization, when it hits you, you really get scared that how do I build something that is once done cannot be changed. I think it's a very, very difficult to comprehend. Suddenly switching gears, and you imagine it. I think like we've always taken our learnings from software, and like trying to not be that person that we have to make one hardware and just ship that, and but I think, to be honest, that has been a biggest shocker, that how do we be in this world of where you iterate so quickly. You do A/B testing every other day. Every platform that you see, let's say booking.com or Zomato, wherever we were, consumer company, there are like hundreds of experiments running, right? You're doing like A, B, C, D testing, right? And seeing your funnels and improving your funnels. But in hardware, how do you do A/B testing as a product, right? So I think that was a big shocker for us, to be honest.
And only a question that a small amount of hardware companies are asking: how do I do A/B testing, or how do I optimize what's out there today? Because it's a software concept.
Yeah. There's a challenge we're trying to solve for it, of course. But I think, to be honest, like we, love iterating and love shipping things very, very fast. And I think that practice we have even continued in our hardware journey as well. So we can double down on that as well. But I think we didn't change our DNA just because we came from software to hardware and became hardware people. I think we have carried that forward. And made sure that org also believes that we need to iterate faster, right? We need to iterate at the speed of software. Of course, there are limitations of physical world that you cannot print a PCB in 1 minute, but maybe in the future we can. But I think that's the DNA that we have kind of carried forward.
So you talked about the software DNA and how that helps you move fast. I think we'll touch on this a little bit later. But talking about the difference between shipping and hardware and shipping software, you mentioned that the thing that was scariest was how when there's a real problem out there, there may not be a fix, right? Like the hardware is busted. You can't ship a software update to fix it. And of course, in your case, there's the additional challenge that these devices are on people's bodies, right? So not only do you not get a chance to fix it, but if it goes wrong, it can go seriously wrong. I think I saw there was a Reddit thread recently of another rainmaker that shall not be named that had the battery swell, and the user had to go to the emergency room because the ring could no longer be removed from their finger, right? And you can imagine some real injuries that would come from a device that doesn't do the right thing. So did you have to change, right? Obviously, when that is the type of stakes, you can't really embrace move fast and break things, right? Because breaking things might mean breaking people.
Yeah.
What did you have to change? How did you update your practices from being a very, very speed-oriented software founder to having to dial it to some extent to, be a good steward or, consider safety?
Yeah. So I think one thing to realize is that no software or hardware is perfect in the world, right? So even a iPhone 17 or whatever, right, that they've shipped, you can't say that it's perfect, right? It never breaks, it never fails, right? So you have to assume the fact that everything that you're writing, that's piece of software or hardware will fail, right? Now how do you build systems to assume that it will fail? So I think from day one we assume that the version of hardware that we're shipping will fail, right? So what that means is that we built a very, very strong cadence of shipping even hardware every 2 weeks. Now what that means is that let's say you find a bug in your circuit design, you kind of always have a better version of the PCB, you always have a better version of the firmware, you always have a better version of design that is out there, which basically you can ship to consumer, right? So it's not about just having design sitting in your laptop or machine which could do better, right? It's actually about making sure that each version that is going out is actually better than yesterday, right? So now, of course, with hardware, the other complexity is that sometimes like you're saying, issues can come in at a later point in time as well, right? But if you think about it, that with the mindset that every 1 to 2 weeks you have to ship a new version of the hardware, a new version of the software, you always are looking out for issues that could come in. Now, of course, we've seen, like in the past, Samsung phones also having issues, but of course, they always had this iterative mindset that, okay, even if it is there, we'll fix it. We'll make better versions which have more safety mechanism, right? No software or hardware is fail-safe, right? It'll never be like it'll not break. Even, Apple, which is world best, has seen, hardware failing.
Even NASA,
Yeah, even NASA for that matter. Yeah, so even after doing so much of testing, you can never say that your hardware is foolproof, right? And that will never happen. But the best thing that you can do is actually going deep into your iterative mindset, always making sure that you're making a version which is better. You have like strong testing mechanism so that you can run and say that, yes, I have covered this scenario. Now it will not fail, right? Of course, you will find something new where you don't have a way of solving it yet. But of course, if you're shipping every 2 weeks, the user who gets like a product today will get it, a better version. So I think that change is what we learned from software. I mean, if your app is failing, you'll not be like, oh, I'll ship it 6 months later. You'll be like, oh, let me ship it today and fix the where the user is stuck at. So I think that mindset is what helping us improve anything that we're facing on the ground. And of course, as we scale globally, we feel that that'll be the strength as well.
So it's more of
Go
a
ahead, Chris.
iterative. I was going to say it's more of kind of a iterative risk mitigation, making that percentage of potential failures get smaller and smaller and smaller based on what you learn. And the slower you are to kind of react to that, the longer it takes to kind of mitigate that risk and learn what's out.
And I think with this approach, actually, we can do a lot of A/B testing as well, right? So you'll see that a lot of our rings that are out there, some are running, they're running some version of the hardware, some are running, let's say have changes that we've done to improve the performance, but we can do a lot of A/B testing, right? Which I think is not very, very popular, in hardware, because people are like, oh, let's build the final version, let's ship it out, and that's about it, right?
I'm curious. I was going to say, I'm sorry. I'm curious when you say kind of iterating on the hardware or changing the hardware every 2 weeks. Like, what does that usually mean for you and the team? Like, what are some of the types of things that would change when you're iterating on the hardware at that pace?
Yeah, so I think even PCB design, right? I mean, as fundamental as that, someone could argue that why do you need a change in PCB design? But I think what you do is, let's say we see some failure on the ground, right? So we'll of course get those rings back. We'll try to break them and see what went wrong. And I think every time you'll have some learning. Like we had learnings that people are using our rings in the Nordics, and some users are in fact in Antarctica, where of course we have not tested the rings in extreme.
Any engineers to Antarctica?
We did test it in scenarios, but I think when you do lab like testing, it's just a point in time testing where you'd be like, oh, it works in plus 50 to minus 20 degrees, but that's like momentary testing, right? When people are actually doing, let's say they're working in extreme, let's say mines or even in military or like that you can't simulate, to be honest, right?
Can't even predict it. I think that's the mistake many hardware companies make, is they're like, we're going to be able to test all the possible environments this device could be in. And like, that's just not, if you look at the number of variables and the diversity across the world of where things can wind up, or devices that make it to space that you didn't, or up in the atmosphere that you didn't expect, like you can't test that matrix of things and ever get a product to market.
Exactly. It's like we had a user who's wearing the ring 6 hours in water, right? Every day. Now think about it, right? How much ever testing we do, even if we have the best of the, IP ratings, we've never tested a human actually swimming for 6 hours every other day, right? In the pool. Now that's real testing. Now, if that ring fails, for example, after 1 month of that behavior, of course, there will be some learning, that, okay, how is the resin like? It could be mechanical, it could be electronics, it could be anything, right? To be honest. And I think that learning is really, really valuable, because that is something that you have context of. If let's say a new company comes in like, oh, I want to build a new ring, of course that context is missing, like you're saying, right? When users test it thoroughly, that you cannot simulate. And I think that's what even large companies have done and built, right? Let's say if you say Apple, iPhone 17, they have seen that 17 versions of iterations and failures, and those are the scars that they have taken, and built the final version that is today in some way.
How many changes to the PCB did you make over the past 12 months? And, you don't have to give me the perfect exact number, but is it 1 or 2 changes, 10 changes, 100 changes? How many times did you change the electrical design in the last year, 12 months for the ring air?
To be honest, like that's what I'm saying. I think every month, at least 1 to 2.
So maybe 20 times in the year, you've changed the electrical design of the device. That's unbelievable. I think most of the projects that I've worked on, most of the products I've worked on might roll out one electrical change over the 3 year that the product is in market for a consumer device.
And this for the device that is running. So of course we have a lot of, like tracks where we of course find out that, okay, there's a fundamental change that we could do, which can actually, let's say like that we cannot, let's say, design in the current form factor. We have to do something, fundamentally different. So that's a different track that would be running. But let's say smaller changes which can actually improve, performance, reliability. I think that's like a core focus. It's like 0 bugs. How do we get to that?
It's super
Chris,
interesting. I think like many I think most of the companies I've been at and most of the companies I talk to, like you mentioned a board spin and people are like, we'll just accept the RMAs that are coming from that. It's not like high enough to justify the risk or kind of like what's in place. But what's lost there is what you're talking about, where like often there's these tweaks to improve battery life, improve RF performance, like lead to a better and better and better experience. And most companies that takes, I mean, if you look at even like the iPhone, it takes like huge periods of time, 10 years, 20 years to kind of work through all the pieces because the board spins, the environmental testing, getting things out there is so slow. And I think as you've been describing this, something I've been thinking about is as like a hardware startup, this is really an accelerator for building your moat, right? Like getting all of this feedback for all these different pieces, refining the tweaks at such a fast cadence. It's not something, I think it's not something that I've experienced at places in the past or talked to folks much about.
I think, to be honest, I think maybe we've been able to do this because we have a manufacturing facility attached to R&D. I think most companies, to be honest, are not able to do this because they cannot actually iterate that fast and change the design and also implement it, right? Because let's say you're working with a third-party vendor. Now he'll be like, oh, give me, 10,000 or 100,000, hardware order, and that is what I can make for you. I can't do iteration for like 500 rings, right? I can't do iteration for like, 200 rings, right? So I think that's, to be honest, that has been the biggest advantage where, when we are co-located, it's like the same, literally one floor is, factory and then, like one floor is R&D. I think it's just beautiful.
I was going to ask what the forcing function was for that, for you all. I think that's something that's really interesting about Ultrahuman is how vertically integrated the stack is. But like, what was the point in time where you're like, hey, we want to spin up, our own manufacturing plants, kind of across the world. I guess you have multiple locations. Like, tell me a little bit about what that looked like and what was sort of the deciding factor.
I think, to be honest, we never thought that we'll do manufacturing because, again, hardware was new and we wanted to build it, but we of course didn't know how to build it. But luckily and unluckily for us, COVID hit, right? So when we were iterating on that, we have to build hardware, and of course, we were looking at the options, and I think we of course were evaluating China as the place that we could make hardware because that is what the world does. Talked to a few vendors, but it like didn't feel like that because there was so much restriction. It was like no way that they could iterate with us. It was very hard to do it remotely completely, and of course it was a new form factor. I think one thing that we realized was that when you have something that is out there and being sold in millions, I think that expertise is already present. It's very easy to iterate with any OEM provider in the world. Let's say you're making a headphone. Let's say technology that is out there, they've let's say done so much production on that you can of course tweak the design and do a lot of iteration on that. But I think ring form factor back around COVID time was very new. There was no companies actually manufacturing it. So I think we realized that I think there's no way of us communicating in the world of COVID, and we didn't even know how long will it last. Right? I mean, there was so much of uncertainty overall. So we thought, okay, let's give it a shot. We'll like a scrappy startup. We kind of took 2 rooms and started building all of that on our own, figuring all the processes on our own. And I think like we just realized that that's so much better to iterate, to kind of work with R&D, to kind of figure out the process. And I think we learned the process with of course a lot of partners. But I think as we started building like let's say 10 rings per day and then 50 and then 100, we realized that there is so much iteration that is still required. When we thought that we were ready with the design, and within no time, like we shipped 20 rings and half of them broke, right? And we are like, oh, what do we do now? We thought this is it, and we have a prototype, we have everything, but like that is when it hit, right? Okay, hardware is hard, right? The name itself has it. So I think we were lucky that we took that call and we were able to scale at our pace and do it and control our destiny in some way.
What were like some of the, I always like to ask, like, what were some of the lessons learned the hard way, or said another, what were some of the biggest hurdles kind of bringing that in-house? I think if you tell people like, I think embedded engineers, I think hardware is hard, but like building my own manufacturing line and getting things to the right place, like I think that's even harder. So like what did that look like?
I think we in fact started off with launching a CGM sensor. So it was the product that we initially launched where you put the CGM on.
Glucose monitor, right?
Yeah.
blood sugar, glucose.
Yeah. So I think we realized when we started Ultrahuman that, glucose is such a core marker of health that in fact, if you see, there are wearables tracking your workout, tracking your sleep, tracking your movement, but there's no workout tracking, your food intake. And if you see, people say that abs are made in the kitchen, and that's the reality. That what you eat is actually 80% of your health, and then of course 20% is how you move, what you do, right? So I think we realized that there's no wearable for food, and we saw that, okay, probably, let's say a CGM or a glucose monitor could be that, product and tool. So I think we started off with that, and we started shipping that hardware, and people started using it. People loved that experience. There was so much, new insight that people started getting. Um, I think in that our learning was that, again, that's also an hardware, and even that used to fail. It's been battle tested for 30 years, right? And we realized that we have no control over it because it's not our hardware. It's of course, like a medical grade, FDA approved sensor, which has been there for like last 30 years. Imagine that sensor has been battle tested for 30 years. Still, it has such a high failure rate, right? And we cannot control anything on it because we didn't know the hardware. We can't control what the sensor circuit is in. What can we? How can we, if we can recover it? There's nothing we could do. I think that's when we realized that we need to control our own destiny by launching our own hardware, by understanding the nuance of why is it failing, and actually adding, like fail-safe loops, or maybe fixing it by software, maybe fixing it by, better quality of hardware, whatever that is, right? And I think that's when we, even thought of building a hardware, and that is when we also thought of manufacturing our hardware, because again, the same issue that imagine our design is great, but if it is not manufactured well, what do you do at that point, right? Is it your problem? Is it manufacturer's problem, right? It's always out in the air, right? So we thought that we need to take like everything, all destiny in our hand, and like it was ambitious back then, but I think it really helped us, scale up, scale down, as we wanted in some way.
Awesome.
Super interesting.
Today, how many locations do you have? How many facilities do you have?
Yeah, so we have two facilities now. One is in Bangalore, of course. That's been our like facility. In fact, we have now expanded it massively. Initially, it was like in a much smaller space, and now we have multi-story manufacturing facility in Bangalore, which I think would love you guys to come over. And if all of you, all the viewers, happy to host you in Bangalore at the facility. Please give me a shout, and we'll take you there. It's an amazing experience. The other one is in Texas, of course, where we started manufacturing our own, rings. There as well. So I think that this is the second one, but we're opening a lot more. So I think that is also on the cards.
And it sounds like this has really been from day one sort of thing. Once you started to build your own hardware, you decided to kind of spin up your own manufacturing as kind of the product volume grew. You also grew your processes and systems with it. Is that correct?
Yeah. I think the amazing thing of Ring as a form factor is that the input and the output both are small. I think the beauty is that in a very small space, you can actually, create a lot of value. So it's not like a EV manufacturing facility where you have like a huge input, right? You have so many components. It's not like, a car, for example, right? You need a multiple playgrounds to kind of make a factory, right? But you could say it's like a bio lab in some format, right? Where your ingredients are so small, and like a handful of rings would be like $1 million, right? So it's and hence I think we have the capability of launching production wherever we want to, because it doesn't need so much of capex, doesn't need so much of like heavy machinery, and hence less of clear, hence everything.
It's mostly manual work.
Yeah. Not manual. I think even the machines that we use, which are automation machines, are very small, right? Because you're working on like microelectronics, right? It's not like, again, a hydraulic where you have to,
Yeah, you're not making a car.
Yeah. It's But
the
value density is very, very high.
One of the challenges I imagine is you now have a crazy wide range of hardware versions in the fields, right? If you change the PCB 20 times in the last year, that means that just in the last year, you have 20 revs of your ring. So how do you manage that complexity? For example, do these sometimes need different software, right? So does your software need to recognize which revision it's on and adapt itself? But also from a QA and support perspective,
Right.
how do you manage, it looks like we have a problem on revision, the March revision of the ring. How do you keep all of these things straight in your head? And has that become a big problem, or did that turn out to be reasonable to manage?
I think we have built automated flows for all of this. Of course, like you imagine, there are multiple versions running which have different hardwares also. Of course, if you have different hardware, then you have different firmwares also.
Yeah, the combinatorials are crazy.
Yeah, it's crazy. So what we've done is that we've built a life cycle of a ring which is unique to itself. So now what that means is that a firmware, can it go to a different version, is also like a, I think what we've done is that we've realized that, sometimes you cannot just say that, okay, this is the firmware version that can go across all hardwares, right? Because there are, let's say we are changing a sensor, right? For reliability, suddenly the driver changes and suddenly everything changes, right? So in fact, if you ship a wrong firmware, the ring will again break, right? It'll stop working and you can't do anything about it, right? So we built completely custom workflows for understanding what version the ring is on and what actually firmware versions can it take even in the future. So that even if, let's say, an issue comes in the ring, we know what troubleshooting to do. We know what fix potentially could go for this ring. And we know there is no fix also, because this is the max that we could do and there's nothing that can be done. So I think we built like really, really automated flows, even for our CX teams to debug. So they don't have to, fly brains into saying that, oh, this is the March revision, oh, this is the, April version. For them, it's all, like grayed out, right? So they don't worry about it. They get an insight that, yes, I've tried everything, system's done, there's nothing you can do. Please change it or whatever, right? I mean, everything is built into the system in some format. So that's our software.
In order to accommodate your speed of iteration, you've had to build your own manufacturing, but you've also had to build your own way to do customer support. Like, you had to build your own software infrastructure to handle that complexity, so that a customer support agent doesn't have to keep in their head the 100 different versions. They get software that automatically tell they're running a version that has this and this problem, and here's the resolution steps. So in fact, you've had to reinvent a lot of the business, not just the manufacturing.
Yeah, I think in firmware also we've done a lot of work in terms of understanding how the rollout should happen. I think that's also one capability that we have built very, very strongly. So we realized that, firmware also is a place that you could have, catastrophic failures, right? Of course, because again, if you have multiple hardware running, how do you, upgrade firmwares and, how do you roll it out, right? Like, for example, there's a lot of A/B testing we do even on firmwares, right? Let's say hardware version A, now there are multiple trials you want to do, which is that, will a battery, let's say you've done a battery optimization track, right? Sometimes in test bench, it will say that, oh, you're getting suddenly 10 days of battery life, but in real world, it's not even close, right? So again, how do you do A/B testing on firmware? So I think what we do is that we built our own, let's say automated suite for rolling out firmwares, like which actually scatter out, meaning in the sense that what we do is that we, as soon as we build a firmware, which we ship very frequently, maybe once or twice a week, even that.
Wow, you do firmware updates twice a week.
Yeah. And what we do is that, of course, we have internal teams who will test it thoroughly, of course, like a large team. And then what we do is that we geo-coded these firmware rollouts, meaning, let's say the factory, wherever the factories are, we kind of first release the upgrades to those areas, extend to areas where we can quickly, ship out.
So you start near the office, so that if there's a problem, you can quickly go there and knock on their door and figure it out for them.
Or replace it. See, the point is that if I ship, if we roll out to places where, we know that we can quickly replace the ring as well, right? In metros, we know that even in few hours, we can send them a ring, right? So we kind of start rolling out, firmwares to places that we have confidence in, and then we slowly scale that up basis, the how the matrices are, right? So we monitor those. I think it's a fun journey where we're also learning. We don't know if this is the right approach, but again, to meet the fact that we have to ship faster, I think we have to build all of this. I think the forcing function is that you have to ship every week, every other week. Now, what do we need to be able to do that is how we think. I think that's been our, journey in some way.
So tell me about what you've had to do. So we talked about the hardware, but of course on the software side, you ship really fast, right? From a couple changes in the hardware every month to a couple changes in the software every week. So what did you have to do differently there? You talked about stage rollouts, A/B testing. is, for example, do you even have a release management team at this point, or are the engineers just constantly owning their own releases the way you would have on a traditional software organization? What structural things did you have to put in place? And were you always able to ship firmware every 2 weeks? Or is this something you got better and better at? Were there specific unlocks? Were there specific things that once you put them in place, it unlocked the velocity? What's
Right.
and what have you gained? What do you see? Can you recall a time where being able to move this fast on software has allowed you to do something amazing?
Yeah. I think what we realized is that in the software world, we had amazing, monitoring tools, right? And that is what we believe very, very strongly in, that, if you can't monitor, you can't solve for that. And that's what you're building for the human body, right? How do you monitor your biomarkers so that you can see the trends, so that you can fix it at the right point, right? That's the mission of Ultrahuman. So I think that we have always seen in software, right? So
And
when we
monitoring
started,
is in your DNA. It's not just your
yeah.
experience as a software founder, but it's also the vision that you have for your business.
Yeah. And I think that same philosophy we wanted to bring, everywhere in every suit that we have. In fact, our revenue is also being monitored. Like, it's something that we see daily, day in, day out, right? The same thing for our hardware as well, right? So we have to ship a firmware as at that pace. How do we monitor that it is actually, running and performing at the pace that we want to, right? So in fact, of course, before, Memfault, we used to do it. We were very scared that we don't know what's happening. It's like black box out there. It's just gone somewhere, and there's no visibility of, is it even running, what is up. I think what we did was that we, of course, pulled in a lot of data from Memfault as well, and we built these automated systems where, we can now understand that, okay, this specific release is not ready to roll out further, right? And I think those, analytic engine is what we've created, and now engineers manage, the rollouts independently, meaning they have the full confidence of saying that, yes, I can push this out to next 10,000, 100,000 users, because I have seen that, okay, all of these, let's say, are done, right? I mean, there's no crashes, there are no, issues, battery is great, all of these things are done in real world. And now I can, let's say, scale it further to next set of, X thousand users. So I think
What are the key metrics you like to look at? You talk about, I think, a very, very interesting process where first internally you want to reach a certain bar of quality using your metrics on your test firmware, and then you ship it to some people and you look at whether you're meeting a bar of quality, and you increase the number of devices that receive that software, and you do this on a twice a week basis, very, very fast. What are the KPIs? What are the couple of things that you look at every time, right? Like if this number doesn't look good, we don't.
one interesting element of our hardware is that it's worn 98% of the time across the day. Now, what that means is that it is always damn on, right? That means that either people just take it out, put it on charger, and otherwise it's always on the body, right? So if the device is actually active and sending data, that's like the, holy grail and the bread and butter in some format, right? So we have to make sure that, that the device is always sending raw markers in some form or the other. If not, then something is off, right? That means that suddenly if the number 98 to it becomes even 7, that means something is off with the firmware. Now it could be, like battery going off, it could be, some crashes happening. Then everything is a side effect of, that number dropping. So we obsess over that, let's say active user, number that
It's an interesting one because it's like the same thing that I found super helpful when I was at Pebble, because we had the same kind of aspect or piece where it's
Time on wrist. Yeah.
time on wrist and kind of the time the connection was maintained. And a lot of people, as people walk away from their device or other things happen. But if you take the aggregate data set, small drops in that number are very indicative of like us doing something that degraded connectivity performance, or I don't know, quite often I felt like it was a new version of Android or iOS comes out and there's something that's changed in the stack that we have to kind of work around or get in place. But a very powerful metric. I also used to think that like devices being connected 100% of the time was a normal thing when you're thinking about Bluetooth. But in practice, like most applications, it's more of like you use it for a little bit, you take it off, but it's really like the wearable market where that becomes something that you really have to think about and optimize for.
Yeah, and I think people use the app like at least 2 to 3 times a day, and they're also getting a lot of value, which is like, their heart rate data, their temperature data, all of that flowing in all the time. So for them, that's the metric that my data should, come in onto the app all the time. And for us, any firmware update should do that, right? And even battery, for the matter, is a second order problem. People should be able to see their data, but on an aggregated basis, you will see that, okay, if the battery goes down, suddenly that number moves from 98 to 96, right? And you're like, what did we push? And suddenly we'll be like, oh, even a small change can, change battery so dramatically, because it's so resource constrained. There's such a tiny battery, like there is so much, so less compute, that even a small, loop can actually mess everything up. So which again, might not be visible in, your testing, but everything looks great, but in real world, things are very, 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 very different.
That's one of my other favorite stats. For low power devices, your goal is basically like, how often can this device be doing nothing in sleep mode for 98% of the time, or whatever it may be. I found that to be a helpful one to track.
And we know from the software world that something as simple as the color of a button can change behavior patterns significantly. And so it comes to it's obvious, or it seems obvious, that small change in device software could lead to big change in behavior, right? It's like, if you degrade somehow the experience of wearing the ring all day, even by a little bit, you will certainly see a drop off from that 98%. People will take it off. They won't even be able to tell you why they took it off.
Yeah.
They took it off because it didn't feel good somehow, right? So I think that metric, figuring out what is the behavior, the behavior that shows success in your product, and monitoring that as the foremost thing, where actually battery life, connectivity success, or things like temperature and others are really only in service of that. They're lagging indicator to some extent of their being, or they're underlying indicators of the actual thing you're trying to do, which is make it a good experience. And if you can measure the good experience, which you guys have figured out a way to do by measuring the wear time, I think that that's really powerful. And too few companies, I think, in the hardware space do that, go as far as defining what is the KPI for a good experience with our products. So I really like that it's front and center for you.
Yeah. And I think, again, of course, Memfault has played that role in terms of us, delegating that work, monitoring to you,
We try
to
to
you
make
guys
it easy.
effectively. Yeah. And I think that's been a big help, to be honest, because our work is doing fast iteration, right? We want to actually break things and make it better, and of course not break in prod, right? And we want to break it in, let's say staging, testing, whatever. But I think that confidence comes in when we know that, okay, we are being monitored, we are being watched, and if things go bad, it'll get notified. We'll get to know it, right? I think it's when you get a lot more confidence into shipping things faster, because you don't want to break, right? I mean, that's not the intent, but of course you will break as well, right? But I think monitoring the data points, I think is really, 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 really key in some way.
The part that I keep thinking about that's so interesting too is your feedback loop for some of the areas that, honestly, I think probably almost no companies have the data, like mechanical board spins, other things. The feedback loop for that type of stuff and the ability for a company to move on it is so slow. Typically, like a new revision comes out once a year, or whatever it may be. At that point, 1%, of a million folks is just like so many kind of customers and things to deal with, where it's sort of this hardware iteration loop you're talking about, mechanical iteration loop you can achieve in the factory. The kind of total percent of people actually ever experience a problem can be substantially slower than most folks in the hardware industry based on that, which is super, super interesting.
You're building a broader range of products. So of course the ring is the one we know the best, but you now have the glucose tracker, right? The GCM, you have the ring, you have, as of this year, I believe, the Ultrahuman Home, which is environmental monitoring product. Have you been able to replicate this approach across all these products? And I guess first, perhaps I assume the GCM is somehow regulatorily encumbered, right? Like it's actually a medical device. Have you been able to replicate this approach of fast iteration on the hardware and software in the context of a medical device, or have you had to, be hampered in that by regulation?
Yeah. So I think again, CGM, that is why we never built it, because, it is actually invasive in nature, and it has very, very strong regulations. So hence we work with the top pharma companies to kind of get that device from them. But again, hence we want to be in the wellness space, because you can iterate, really fast and ship and iterate on it. But I think if you have a regulated device, I think the downside is that you really need to be perfect, and you can't iterate on it. In fact, some of these CGM devices are a 10-year-old, meaning you can't even update, forget the software, forget the hardware. You can't change the app also for 10 years.
Exactly. Even the software around it cannot change. And by the way, for good reason. I think there was a story in the news maybe a year or 2 years ago, that a change in the iOS app for one of those, I forget whether it was a CGM or one of those that actually has the insulin in the loop also. But anyways, it was a device for folks with diabetes.
Right.
And they shipped an update to the iOS app. And the update to the iOS app increased a lot the number of messages the iOS app, by mistake, the iOS app was sending to the device, which led to more battery consumption of the device.
Yeah.
Which led to the device dying halfway through the day for a bunch of users, which led to hundreds of people in the hospital, right? And you think about that, like the butterfly effect of one bad line of code in the iOS app, hundreds of people in the hospital. And so you understand the balance that the regulator has to strike between enabling innovation, enabling iteration on the one hand, and on the other hand, making sure that we're not pushing our luck too far with the A/B tests.
And hence, I think what we have decided and we strive towards is that we, of course, keep the hardware as a wellness product, but what we are building is software as a medical device, right? So we are the only company in the world, and only ring company in the world, that has AFib detection as a medical device and FDA approved in tons of countries out there, right, in the world. So and that, of course, we are able to do because it's something that the data that the sensors provide, you're able to build algorithms on top, get it approved by the authorities, and actually you can take that report to a doctor and say that, hey, I think I have a AFib. Can you please prescribe some medication? Can you suggest something to me? Because Ultrahuman Ring says so, right? So I think we are going towards that direction where we will build software and get it approved, like from the medical fraternity, and keep the hardware as a wellness product. But maybe tomorrow we have hardware as a device as well. But I think in that case, of course, we'll have to make sure that hardware we don't iterate on a medical grade hardware. I mean, that has to be completely tested, battle tested, and then approved, right? So I think the approach has to be very different for both.
So with the Ring and the home device, did you decide, is there a shared platform under the hood? In other words, are you using a common code base on the embedded software side? How much is shared? How much is separate? Right. And how has that worked out in terms of your ability to move fast?
Yeah, I think we completely believe in sharing code bases across hardware, right? So in fact, all the future things that we are launching are on the same architecture, are on the same design. So every new version of the Ring, every new version of Home, every new version of any other wearable that we launch will have the same architecture and design. And I think that is really helped us.
Oh.
Yeah. It's one repo, just some, you could say, some configurations being different
configurations.
So it's a completely like shared across, and I think we've seen that advantage in a lot of iterations. Of course, like not going to talk about a lot of things now, but you'll see it soon, right? A lot of things that we are going to launch are iterated so quickly, just because we have not reinvented the wheel of building, let's say, a new firmware, or doing fresh integrations and all of that. I think it's like the same iOS ecosystem, right? You kind of have the same app can work, in your Mac, can work in your iPad with a little bit of tweaks. And I think that's the same approach that we're taking for firmware as well, in a very strong way.
Really cool. So has it happened? Does it ever happen that your engineer working on Home makes a change, and then the engineer working on Ring runs in and is like, "What did you do?"
Of course,
is there
right?
some conflict? Because the Home is plugged into the wall, right? It's infinite power. So sometimes they don't really care.
Yeah. So I think of course, like I think again the advantage that team sits together, the production is like just around. I think everyone is in fact rotating across like hardwares. It's not like there's like one person just having context of home. So I think people always share context. So I think it's about if you have context of the code and you kind of work together, I think it's relatively easy. But of course, we always have issue that will come up. But again, hopefully till staging, I think hopefully till dev, not beyond. I think luckily till now done. So we are good.
How much automated testing do you do? So of course, we've talked a lot about your A/B testing and production monitoring, right?
Right.
But one of the things we did at Pebble, for example, is every commits had some amount of automated testing run on them. And every night we ran nightly tests. We had racks of dev boards and racks of watches with every mobile phone possible. And we did battery regression testing, all of that every night on basically on custom designs, test infrastructure. How far have you pushed that part of it?
Interesting, like element is that we have designed a new machine to simulate how heart rate is generated, right? So it's like basically the issue is that let's say I change, the firmware. Now you're suddenly your heart rate changes and your HRV changes, your algorithms change and everything breaks, right? So even a small change could actually break all the algorithm. And again, we are software as a medical device, and and hence we have to be responsible in terms of what we push as a change, right? So we in fact built a hardware which is grounds up built by us, where basically you put anything on top, it can simulate like a human's behavior, right? Which is like running. What's like you're running, it can simulate that. Oh, your heart rate is going from like a 70 to a 120, 140, right? And you can actually automatically test that. Hey, I've given you, now let's say 100 or 110, 120. What are you giving me back, right? So I think we built a lot of such cool, tools and products that help us, do these micro iterations for our rings. And of course, would love to host you and show you in action. I think we of course don't publish all of this because it's a lot of cool IP, but I think if you visit, you
We'd
would
love to see some blog posts someday.
That's a cool problem in and of itself.
It is. There's a lot of cool things being built. In fact, we have tons of like machines built for let's say manufacturing process itself. Right, we have to automate so many things because again, like polishing is so hard. Things like again putting sensors in is hard. So of course we started off with like people doing it, but we realized that even one mistake causes some failure. So there was a learning. And then we would build like a machine.
What's the shape of folks you've looked for to solve some of these problems, like kind of custom manufacturing devices?
Where do you find these engineers?
It's kind of niche skills.
Yeah, I think we have people from various backgrounds, like again defense and EV. And but to be honest, like India doesn't have as much of wearable manufacturing or firmware talent, right? And I think team has grown like learning and building together. So I think it's completely folks jumping in, solving that problem. Firsthand. It's not like they had experience and understood, oh, this is how it is done, and they kind of solved it, because that kind of product firstly doesn't exist. And the challenges are very unique in some format. Like we are manufacturing like such unique things. It's like, okay, now how do we solve it? We don't know how to solve it, but it's a pain point. Let's figure out what what we can do. So we will talk to other people and figure out and design something unique. In fact, we designed like one of the like an amazing like a polishing machine. Of course, would love to show you. It's so beautiful. Like the thing that used to take 30 minutes to kind of polish, because it's like a ornament that you wear, right? I mean, it has to be like picture perfect. You take the ring out and it's something like a jewelry. And we built a machine that let's say polishes the ring in 20 seconds, right? And it's beautiful. It's perfect. It like doesn't have any scratches at all, right? So suddenly from like minutes and hours of effort, it just turned into like a few seconds work, right? And with accuracy. I think that's cool as well.
Maybe you can send us a video. We'll put it in the show notes. I think people would really, really be interested to learn about that.
Yeah.
Let's close by talking a little bit about what you see coming in the future. So, of course, we talked a lot about development best practices, but maybe let's talk about technology for a bit. What technologies are you excited about, and where do you see, what areas you see you're going to see big innovation coming for Ultrahuman?
Right. I think, of course, like world is talking about AI, and like
So
there is
tell me about
no
AI.
there's no conversation in the world that doesn't start or end with AI. So
Right.
I think of course we have to talk about it. But I think we look at AI very differently. I think again, like we are a health platform, so we have to be, like you're saying, very responsible in terms of what we offer to our users, to our consumers. Of course, if someone gets an AFib alert, we can't let AI drive and tell that, hey, take a statin, that won't work. So I think
Mhm.
we have, from a consumer, lens, we've been a little cautious in terms of, how to showcase AI, in the workflows, because we have seen that, it does make mistakes still. We've not achieved AGI yet. So it does make mistakes. And I think we are very, very bullish on the technology internally, right? I think there is no work that happens which doesn't use it inherently. Be it, of course, engineering is obvious, but I'm saying everything that we touch today is mandatorily run by.
Are you doing some AI at the edge? Are you doing it all in the cloud? And how do you think about battery, power management?
Yeah, so I think, to be honest, we do a lot of ML, ML on the edge, ML on phone. Of course, AI that we do is, of course, on servers for compute, for
Yeah.
doing a lot of R analysis. But I think the most part of it is today is ML. Right? Don't want to just say it's AI for the sake of it, but it is actually hardcore ML.
Right.
And I think tons of our workflows do use AI within. I think it's mandatory in every team to kind of even if you have to ask a question, you first make sure that you have an answer from AI, and then ask that question. Even our legal teams are so aggressive on AI nowadays.
Awesome. Well, on that note, we're at time. This was a tremendous conversation. So impressed every time we chat about with the speed of iteration, the level of sophistication that you and your team employ at Ultrahuman. More you're further into the world of using software methods in the hardware space than any company I think that I've had the chance of talking to. So congratulations, keep doing it. I'd love to hear more as you continue polishing and improving that approach. And I want to say a big thank you for the time you gave us today and the great answers you shared earnestly. That was really fun.
Thank you so much. Thank you. Yeah. Thank you for building
Super cool.
Memfault, and thank you for giving this opportunity to us to kind of iterate just faster. I think that's it's been a strong like hook in our journey in some way, right? So kudos to you guys as well.
Thanks for tuning in to this Coredump session. If you enjoyed the conversation and want to dig deeper, check out more episodes available wherever you get your podcasts, on YouTube, or at memfault.com/webinars. If you have any questions for our team, drop us a line at team@memfault.com. Until then, keep shipping. See you next time.